Now on this slide, we present the equation of a hyperbola with center at the origin and transverse axis along the y-axis. And the theorem states an equation of the hyperbola with center at 0, 0, foci at 0, -c and 0, c, and vertices at 0, -a and 0, a is y squared divided by a squared minus x squared divided by b squared equals 1, where b squared equals c squared minus a squared. Now let's notice that the distance from the center to either vertex is a, and thus the distance between the vertices is 2a, and furthermore, the hyperbola has no x-intercepts. Additionally, there are no points on the graph for any y values between -a and a. Let's take a moment to make a couple comparisons between the two equations we have for a hyperbola. For the equation x squared divided by a squared minus y squared divided by b squared equals 1, note that the transverse axis is along the x-axis. For the equation y squared divided by a squared minus x squared divided by b squared equals 1, note the transverse axis is along the y-axis. I like to recognize this as being related to which term is being added on the left side of the equation. In other words, note for the equation x squared divided by a squared minus y squared divided by b squared equals 1 that the y squared term is being subtracted and thus the x squared term is being added. Now, since the x squared term is being added, then the transverse axis is the x-axis. Now similarly, for the equation y squared divided by a squared minus x squared divided by b squared equals 1, the x squared term is being subtracted and thus the y squared term is being added. And since the y squared term is being added, then the transverse axis is the y-axis. Now let's make a few notes. For both equations, note the center is at the origin. Also for both equations, the vertices are a distance of a from the center along the transverse axis. And similarly, the foci are a distance of c from the center along the transverse axis. In this example, we're told to analyze the equation of the hyperbola 2y squared minus x squared equals 8. Now first, we need to divide both sides of the equation by 8 to put it in the standard form. Now doing so gives us an equivalent equation of y squared divided by 4 minus x squared divided by 8 equals 1. So the equation matches the form y squared divided by a squared minus x squared divided by b squared equals 1, where a squared is 4 and b squared is 8. Now, since the x squared term is being subtracted and thus the y squared term is being added on the left-hand side of the equation, then we know that the transverse axis is the y-axis and the center is at the origin. Now let's find the vertices. Now we know that they are a distance of a from the center along the transverse axis, so they will lie at the points 0, plus or minus a. Now since a squared equals 4, then the vertices are 0, plus or minus 2. Now let's plot these 2 points using a coordinate grid that goes from -6 to 6 on both the x and y axes. Well, let's plot v sub 1 at 0, -2 and v sub 2 at 0, 2. And again, note the convention here is to label vertices chronologically, so v sub 1 is below center and v sub 2 is above the center. Now let's find the foci. We know that b squared is equal to c squared minus a squared, or c squared is equal to a squared plus b squared. Now since a squared equals 4, and b squared equals 8, then we have c squared equal to 4 plus 8, which is 12. Now, we know the foci are a distance of c from the center along the transverse axis, so the foci lie at the points 0, plus or minus c, which is 0, plus or minus square root of 12, which simplifies to 0, plus or minus 2 square roots of 3. Just to get an idea where these lie, we can use a calculator and find 2 square root of 3 to be approximately 3.5. So on our coordinate grid, let's plot f sub 1 at the point 0, -2 square root 3, and f sub 2 at the point 0, 2 square root 3. And the last thing we need to do is plot a few more points to sketch the graph. Let's move on to a new page with some blank space. So we want to plot a couple points to the left and right of the foci that have a y-coordinate of plus or minus 2 square root of 3. So let's use the original equation, 2y squared minus x squared equals 8, to substitute in those y values. So the equation would become 2 times the square of positive or negative 2 square root 3 minus x squared equals 8. Squaring positive and negative 2 times square root 3, we would end up with 2 times the quantity, 4 times 3 minus x squared equals 8. Or we have 24 minus 8 equals x squared, which is 16 equals x squared. Therefore, x would equal plus or minus 4. So we now have 4 points we can plot, 2 on each branch of the hyperbola. So I'm going to sketch the lower branch first. Let's plot a point at negative 4, comma, negative 2 square root of 3. And then let's plot a point at positive 4, comma, negative 2 square root of 3. Connecting these 2 points with v sub 1, we sketch the lower branch of the hyperbola. Now let's draw the upper branch. So we'll plot a point at negative 4, comma, 2 square root of 3, and positive 4, comma, 2 square root of 3. Connecting those points with v sub 2, we sketch the upper branch of the hyperbola. In this example, we find an equation of a hyperbola. This problem says to find an equation of the hyperbola that has one vertex at 0, 3, and foci at 0, negative 4 and 0, 4, then graph the equation. So I like to begin by plotting the given information. So using an xy grid, that's negative 6 to 6 on both the x and y axes. We are told one vertex is at the point 0, 3. Let's also plot the 2 given foci at 0, negative 4 and 0, 4. Recall that the vertices and foci lie along the transverse axis, which in this case is going to be the y-axis. So in that case, we know the equation will have the form y squared divided by a squared minus x squared divided by b squared equals 1. Well, let's follow the convention and we will label the points chronologically as the y values increase. So let's come back to our graph and let's label the focus at 0, negative 4 as f sub 1. Then we will label the focus at 0, 4 as f sub 2. And since the foci are equidistant from the center, then we know the center is at the origin. We are given the upper vertex at the point 0, 3, so let's label this point as v sub 2. And since the vertices are equidistant from the center, that means v sub 1 is at the point 0, negative 3. Since the vertices are a distance of a from the center, then we know that a will equal 3, which means a squared equals 9. Now also, the foci are a distance of c from the center, therefore c is equal to 4, or c squared is equal to 16. Now we need to find the value of b squared. So for a hyperbola, b squared is equal to c squared minus a squared, which equals 16 minus 9, or 7. So for the general equation of the hyperbola, y squared divided by a squared minus x squared divided by b squared equals 1, we can write y squared divided by 9 minus x squared divided by 7 equals 1. Thus we have found an equation of the hyperbola as requested in the problem statement. So to finish the problem, we're going to complete the graph of the hyperbola. So again, it is helpful to locate and plot a few other points on the graph. We'll plot points to the left and right of each of the foci that have a y-coordinate of negative and positive 4. So let's substitute y equals positive and negative 4 into the equation that we just wrote, and we will have 16 divided by 9 minus x squared divided by 7 equals 1. Now adding x squared divided by 7 to both sides of the equation and then subtracting 1 from both sides of the equation, we can write 16 divided by 9 minus 1 equals x squared divided by 7. This simplifies to 7 divided by 9 equals x squared divided by 7, or x squared equals 49 divided by 9, which gives us x equals plus or minus 7/3. Now let's plot the 2 points on the lower branch of the hyperbola. Keep in mind that 7/3 is approximately 2.3. So we plot points at -7/3, -4, and 7/3, -4. Connecting these 2 points with v sub 1, we get the lower branch of the hyperbola. Then let's plot the 2 points on the upper branch at the point -7/3, 4, and 7/3, 4. Connecting those 2 points with v sub 2 gives us the upper branch of the hyperbola.